Buongiorno, mi chiamo Joseph, but I will continue in English anyway. For those who do not know me yet, I am an independent CDISC consultant and my company is also developing and marketing software in the area of CDISC standards. I am also a CDISC volunteer for more than 20 years and have developed a lot of the core rules for CDISC, especially for the FDA business rules and CENT. Let us first start with the current state of core implementation at sponsors, CROs and service providers. Core is now very well established in our industry, as it is far superior to anything else in the field of CDISC validation. This due to the very high quality of the rules and, very important, full transparency on how the rules have been implemented, this opposed to the black box implementation of other offerings. Furthermore, Core is completely free and open source. Also unique is that companies can add their own internal rules to Core. Companies have started building a graphical user interface on top of Core or have incorporated Core into their own tools, including mapping tools. This means that you can already use Core during the mapping effort, and you don't have to wait until all your datasets have been generated. Available tools include the open source Smart Submission Dataset Viewer, Bioforum Submit 24, Epsilon Web Core implementation, which is a very interesting one, and you should really try it out, but of course there are also several others. This is a screenshot of the Smart Submission Dataset Viewer. When during loading the datasets, the checkbox Perform Core Validation is checked, the application will also execute Core on the loading datasets. With the button Validation Rules Selection, the user can even select or filter which rules will be executed. So it is not everything or nothing. The user can, for example, select to only execute the FDA rules or only the CDISC rules, or by class in the case of SDTM and CENT. It even has a search engine, so that one can, for example, only select the rules that are about age. Once executed, the generated tables pick up the results of the core execution and colors the cells for the data points for which a violation was found. It also shows the error messages when hovering the mouse over the cell. In this case, it found violations for RFX, STDTC and for 2 rows for a subject in this DM dataset. But the main topic for today will be about the development of custom rules. With Core, you can not only develop custom rules in YAML or JSON, but you can also add them to the Core engine itself as a so-called custom standard, and you can even version these. For example, a CRO may have different quality or consistency rules for different sponsors, projects and studies, and generate and maintain these as different custom standards. Custom rules can, however, also be executed on an individual basis. For editing in YAML or JSON, you can use one of the many available editors, including online editors. Personally, I prefer YAML, as at least for me, this is easier to use. We are currently also developing a Core-specific YAML editor, which understands the schema of Core and which we intend to make freely available and as open source. On the right side, you see such a very simple rule in YAML that states that when the age unit is years and age is higher than 65, then a violation needs to be generated. This is a somewhat more difficult rule, stating that when VS-TEST-CD is either CysBP or DiaBP and VS-POS is present and populated, then the value of VSPOS must be one of the 5 allowed values. Another one is that when the lab test is white blood count and VSRS is populated, then its value must represent a number. For those who know already a bit about biomedical concepts and SDTM Dataset Specializations, this already looks pretty related. So that will be the topic of the remaining of the presentation. What are SDTM Dataset Specializations? Essentially, they are nothing else than SDTM implementations of the CDISC biomedical concepts. For example, for the biomedical concept systolic blood pressure, the SDTM Dataset Specialization adds the SDTM specific implementation features, such as the allowed units, the allowed or expected values for the location of the measurement, the allowed values for VSPOS, and so on. In April 2026, the CDISC library contained 1,326 such dataset specializations, which we can retrieve using the API. Essentially, all these SDTM dataset specializations can be seen as defining rules, or at least best practices. So I was wondering, can't we generate custom rules from them in an automated way? The answer is of course yes, otherwise I wouldn't be standing here. So how did we do that? We wrote a very small program, less than 2000 lines, that queries the CDISC library for all dataset specializations using the API. For each of these, we look for the objects that are not so-called value-level metadata targets. These become the preconditions of our rule. For example, that VSTCD equals WSTCIR, waist circumference. We then also look for the objects that are VLM targets. These become the postconditions. For example, that VSRS represents a number, or that VSRSU is expected to be one of centimeter, inches, or millimeter. So, if we have, for example, 5 VLM targets, this will lead to 5 postconditions and thus 5 rules. No panic, I will show in a moment. For each of these, we then transform the information to YAML and write it to file. This then leads to a total of over 6,400 core rules. 6,472 is of course a lot, so let's try to categorize. Over 1,100 are test name, test code rules. Surprisingly, it looks that in the original core rules, there is no rule checking the one-to-one relationship between test code and test name. But we have it now. 2,500 rules are about the expected data type for the result. For example, that the value for sysbp is a number. Over 2,000 rules are about allowed values, for example for SDTM variables. And over 500 rules are about a single value assignment, for example for yes-only flag variables. Let's look at an example for waist circumference. This is part of the JSON we get from the CDISC library and the API for the dataset specialization. It defines a precondition stating when VSTCD equals WSTCIR. Then we continue. In the same dataset specialization, we find a value level metadata target stating that the value of VSRS is expected to be a number. And another one stating that the value of VSRSU is expected to be one of centimeters, inches or millimeters. So this will lead to two core rules. And here is the first core rule. It states that when VSTestCD equals WSTCIR and VSORIS is populated, as it can also be a not done record, then throw an issue when the value of VSORIS does not represent a number. The second rule states that when VSTestCD equals WSTCIR and VSORIS-U is populated, then its value must be one of centimeters, inches or millimeters, otherwise an issue is generated. 6472 automatically generated rules is a lot, so the question arises, can we trust them? We need to curate. Fortunately, most rules are very simple. Test name versus test code, data type verification for variables such as ORIS and SDTM, enumeration of allowed values for variables such as ORIS-U and SDTM, enumeration of allowed values for variables such as spec, log, and so on. These are mostly about subset code lists, but even then. Sometimes one needs special attention. For example, for white blood cell count, the expected standardized unit is 10 to the 9th per liter when the specimen is blood. However, LB-spec is permissible. So, what to do when LB-spec is absent or not populated? It is important, as for LB-spec is urine, the expected unit is 10 to the 6th per liter instead of 10 to the 9th per liter. So, how do we bring these rules into the core engine? It is pretty easy to define custom standards in core, and that is exactly what we did. If you want the technical details about how this is done, this is very well explained on the core project website on GitHub. Then we deployed the extended core engine on several of our software tools, such as the Smart Submission Dataset Viewer and our SDTM ETL mapping software. Here is a screenshot of the GUI of our mapping software. When starting the execution of the mappings, there is a checkbox Perform Core Validation. It is then asked which sets of rules must be applied. And one can then even explore the rules and make selections. In the Selections dialog, one can then apply filters on almost anything. In the graphical user interface, with the result SDTM tables, the records or cells that violate one of the rules are then highlighted, and an issue message is shown as a tooltip. For example, in this case, for erythrocytes, the unit in LB-STRS-U is expected to be 10 to the 12th per liter, not 10 to the 9th per liter. Also remark here that the cells for LB test for erythrocytes are highlighted, as erythrocytes is not written correctly. This is detected from the specific core rule checking the one-to-one relationship between testcd and test. Summary. With core, custom data quality or consistency rules can easily be developed. Groups of such custom rules can be grouped into custom standards and versioned. That is what we did for rules that were generated in an automated way starting from the SDTM Dataset Specializations and added them as a custom standard to the core engine. What I also learned in the last months is that it is pretty easy to incorporate CORE into existing software or build a graphical user interface on top of CORE. This to make the use of CORE extremely user-friendly. Grazie mille. Ci sono domande?